So students, today we are going to discuss another topic, that is electrical machines. I am Professor Vasant Acharya and I will be giving you an insight about the electrical machines. Now we will be covering the following points: introduction to electrical machines, DC machine overview, working principle of DC machines, construction of DC machines, types of DC machines and losses and efficiency, three-phase induction overview, working principle and construction, types of induction motor, losses and efficiency, three-phase synchronous generator overview, working principle and construction, types of synchronous generator, losses and efficiency. Now when we are talking of this particular topic, we will start with introduction to electrical machine. Now what is an electrical machine? Electrical machine is the one which converts one form of energy to another form. For example, if we talk of a category called motor, so motor converts electrical energy to mechanical energy, whereas generator converts mechanical energy to electrical energy. The types of machines are DC machines, three-phase induction motor and three-phase synchronous generator. If we talk of DC machine, in DC machine we have DC motor and DC generator. DC motor is the one which converts electrical energy to mechanical energy, and DC generator is the one which converts mechanical energy to electrical energy. Both the machine works on the Faraday's law of electromagnetic induction. So if we talk of the key equation, that is E equal to K phi N, motor action, force on current carrying conductor in magnetic field, and generator action, voltage induced in the conductor moving in the magnetic field. In motor we have force on the current carrying conductor in a magnetic field, that is why it rotates. In generator, a voltage is induced in the conductor moving in the magnetic field. As a result, current flows through the load. Now if we talk of the main components, the main components are stator, that is the stationary part, basically field poles which produces flux, frames and brushes are the stationary part. Rotator is the rotating part, that is the armature, core, commutator and winding which rotates. The field system is the one which produces magnetic flux, and armature is the one which produces power producing winding. Commutator is the one which converts AC to DC in case of generator and DC to AC in case of motors. Brushes are the part which collect current from the commutator. Types of DC machines. The types of DC machine are basically mainly two types. Number one is separately excited, which means field and armature circuits both are separate in identity, whereas in self-excited, armature circuit and field circuit are connected to each other. The self-excited machines are of three types. Shunt wound, in this field system is in parallel, a field winding is in parallel with armature. In series wound, field windings are series with armature. Similarly, in compound wound, both are in series and parallel combination. The losses which are occurring in DC machines are copper losses, iron losses, mechanical losses and brush contact losses. So copper losses occurs in armature and field windings, iron losses or core losses occurs in the magnetic field system which causes hysteresis and eddy current loss. Mechanical losses are basically due to friction and windage, and brush contact losses at commutator brush interface. Efficiency is given by the formula output upon input. So it will be equal to input minus losses upon input into 100 in terms of percentage. Now we talk of three-phase induction motor. This is another type of three-phase induction motor. In this we have most common industrial motor greater than 80%. It is self-starting, robust and low maintenance. Operating principle is rotating magnetic field, and the base of operation or the basics is slip. That is the difference between the speed of the rotor and magnetic field. Now if we talk of the working principle, in working principle of three-phase induction motor we have a stator and a rotor. The stator is fed through a three-phase AC supply. As a result, it produces a rotating magnetic field around the rotor. This synchronously rotating magnetic field cuts the rotor conductor. As a result, an EMF is induced in the rotor conductor as they forms a closed circuit. This causes a current to flow in the rotor conductor, which again produces a rotor magnetic field. The interaction of the rotor magnetic field and stator magnetic field exerts a force on the rotor. As a result, it rotates in the direction of stator magnetic field and it tries to catch up. The difference in the two speed is called as slip. Now, if we talk of the construction, in construction we have stator. It is a three-phase winding in which windings are placed 120 degree apart in the slots. Rotor is of two types: squirrel cage, in which bars are shorted by end rings, whereas phase wound in this three-phase winding is placed on the rotor with slip rings. Based on rotor construction, we have squirrel cage induction motor. Advantages are simple, robust and low cost and fixed speed characteristics, whereas wound slip ring motor, it has external resistance control and high starting torque applications. Losses and efficiency induction motor. Losses are stator and rotor copper losses. Then core losses, that is stator and rotor losses. Mechanical losses, that are friction and windage losses, and strain load losses. The efficiency of three-phase induction motor comes under four categories: standard efficiency, high efficiency, premium efficiency and super premium efficiency. Similarly, a three-phase generator is also there, which is called as three-phase synchronous generator. This generator is the primary power generation device. It has constant speed operation. The frequency is given by the formula Pn divided by 120, where P is number of poles and is speed of rotation. It is generally used in thermo, hydro, nuclear power plants and can operate at leading and lagging power factor. Working principle of three-phase generator, synchronous generator. The three-phase synchronous generator is basically has two parts: rotor. Rotor is the rotating magnetic field. The rotor on rotor we have got the magnetic poles which produces magnetic flux. This rotor is rotated by a prime mover, and this rotor flux cuts the stator conductors. As a result, an EMF is induced in the stator conductors and which causes a current to flow in the load. This prime mover can be driven by various types of turbine: water turbine or steam turbine. In construction, we have stator, which is made up of three-phase armature winding, which are placed 120 degree apart to form three-phase winding. Field windings with DC excitation, that is rotor. Rotor is of two types: salient pole, it is a low speed and driven by hydropower. Second is cylindrical rotor, it is high speed driven by thermal power. Exciter is the one which supplies DC to the field windings, which are placed on the rotor to magnetize the magnet. So based on types of construction, we have silent pole rotor, which is large in diameter and low in speed; cylindrical rotor, which is small in diameter and high speed. The losses are same as induction motor. We have copper losses, which occurs in armature and field system; core losses, mechanical losses, excitation losses and strain load losses. Typically, the efficiency of large generator is 95 to 98%. Now, if we compare the three machines, that is DC machine, three-phase induction motor and three-phase synchronous generator, we have, in terms of speed, DC machine, the speed is variable. In three-phase induction motor, it is nearly constant, whereas three-phase synchronous generator, it is constant. Then we got of control. Speed is easily controlled in case of DC machines. In three-phase induction motor, it is difficult to control, whereas in three-phase synchronous generator, it has got a fixed speed. In terms of maintenance, DC machine has got high cost of maintenance due to maintenance of brushes. Three-phase induction motor has got low maintenance, and three-phase synchronous generator has got moderate maintenance cost. Efficiency of DC machine is between 80 to 90%, whereas 3-phase induction motor are 85 to 95% and 3-phase synchronous generator efficiency is 95 to 98%. The applications of DC machine in traction and cranes, whereas 3-phase induction motor is used in pump, fans and conveyors, and 3-phase synchronous generator is used in power generation. So this is all about the electrical machines. Thank you.